Alrighty, we're going to do a Unit 1 test review. So if I want to put this function in standard form, what you first want to know is cubic means write 3 of them. And then you need to FOIL or box the first two. When I do that, I get this. Now I have this, which replaces that. Alright, and you still have this x minus 5 I put at the end. Now to multiply this trinomial times a binomial, I'm going to use this box method. I put the x minus 5 on one side and put this on the other side, and then I multiply each side like a multiplication table. And then once we do that, you combine like terms. See, the x squareds combine and the x's combine, and you get this standard form polynomial. So this is a third degree polynomial. Next question is, verify that 5 is a 0 of f of x. Well, you can use this new function you made in standard form to verify 5. You can do it by doing synthetic with 5, and the 1, negative 15, 75, and negative 125. And then when you do synthetic, if it gets a remainder of 0 here, you have a 0. Or you can simply look at this format right here, which is another version of this, and realize your zeros are when a factor equals 0. So when you set the factor equal to 0, you get 5. Or you could simply plug 5 into the function, either one, this one, or this one. This one's easier. And when we do that, we get 5 minus 5 is 0, 0 cubed is 0. So if you get an output of 0, that means it's a 0. There's even more ways of doing it, but these are 3 different ways to verify a 0. Lastly, I want to find the y-intercept of f of x. Well, what you're doing for a y-intercept is you're putting x as 0, or putting 0 in for x. So you could put 0 into this function, or you could put 0 into this function. So if you put 0 right here, as you can tell I did right here, I get negative 5. Negative 5 cubed is negative 125. Or if you put 0 into this function, as you can see right here, that becomes 0, 0, 0, leaving you just the end. Something you want to know about standard form is the constant at the end is always the y-intercept, if it's in standard form. So you can plug it in to find y-intercepts. So for this one, we want to put f of x in standard form. So right now, f of x is a subtraction of 2 polynomials. So when you subtract, what you do is you leave the front, and when you subtract, you are adding the opposite of each of these. So the opposite of x squared is negative x squared. The opposite of negative 6x is positive 6x. And the opposite of negative 1 is positive 1. So what we now do is we now combine like terms. So nothing combines with the cubic. So that's first. We always start with the highest power. Then we have an x squared as the next thing, and nothing combines with this, so we have negative x squared. Next comes x's, and we combine those two. We get 8x, and we combine these two. The last terms are units. We get negative 4. That's standard form. So what you should know, to first of all, to tell if f of x falls on the left, first we have to realize it's a third degree, and the lead coefficient is a positive 3, but positive is what we're looking for. So because it's a third degree, we know it's odd. And because it's positive, we know on the right side it's going to go up. Since it's odd, the left side is going to go down. And we want the left side, so it's going down. It's falling. So yes, it does fall on the left, but it rises on the right. So next, is x plus 1 a factor of this function right here? Well, if I want to know if x plus 1 is a factor, we have to check this factor is 0. So the 0, what would make this 0 is negative 1. So we test the negative 1. And I'm using synthetic. So when I use synthetic here, I plug in negative 1, and my result is negative 16. So for it to be a factor, negative 1 would have to be a 0. So no, this is not the case. Now, you don't have to use synthetic. You could also put negative 1 into this function and crunch it. And what happens is we get that negative 16 as well. So either way does work as well. Or you could long divide this by x plus 1. There are different methods. I think this is the easiest. Last one. Does f of x divided by x minus 2 have a remainder of 8? So that's kind of the same question as this, because what we're going to do here is we're going to take the 0 of this, which would be 2 minus 2 is 0. So we do 2, use synthetic, and then when we get it, we got 32. Now that is actually a remainder. Okay, so if you plug in 2 as the 0 for this, the output in synthetic is the remainder. So is it 8? No, it's not. It's 32. So it does not have, it has a remainder of 32, not 8. All right, this next question here, what is f of 2? For this is f. So we could simply plug 2 in each piece and crunch it. But again, I think synthetic is easier to find f of 2. You do not do the opposite because it's like testing the 0. And when I put 2 into this right here, you get 0. Now be aware, see this 0 right here? You need to put a 0 placeholder right there at the end. A lot of people would forget that 0 at the end, so be careful. So f of 2 equals 0. Next, what does it do on the left? So on the left, let's look at this graph real quick. It's a positive cubic. So it's the third degree, odd, and it's positive. So we know the right side's going to go up and the left side's down because odds go opposite. So on the left side, this side, it looks like it's falling. On the right side, it looks like it's rising. Now this one is 2 is 0. Well, if right here we check 2 and it got 0 out, doesn't that mean that 2 is a 0? So really, you don't have to do any work. Now if you want to check if 2 is a 0, this is what you do right here. Or you put 2 into this and see if you get an output of 0. Next, is x minus 4 a factor of this? Well, to check that, we simply are going to check the 0 of x minus 4, which is 4, because 4 minus 4 is 0. And we use synthetic. Again, don't forget the 0 at the end. And we get 64 out. So since this is not 0, it is not a factor. So as you can tell, synthetic is very powerful. It does a lot of things for you. All right, for this problem, at what x value is there a minimum? Well, minimum, let's see, is right there at the bottom. Looks like the only minimum is right there. That's a max. That's a max. So there's the minimum. So what x value did that minimum happen? It's at 1. Okay. What is the average rate of change on negative 2 to 3? So negative 2 is right here. There's a blue dot. And 3 is right there. So the average rate of change is the slope. So let's see. We went 5 over and 2 down. So just remember, it's rise over run. So it's 2 over 5. And it's going downhill. So that's why it's negative. On what interval is it increasing? Well, let's see. What I highlight in yellow are the increasing intervals. So this first interval is from negative infinity all the way to, what I say, negative 2.5. And also from 1 here to 3, it is increasing. It's decreasing from here to here and from here to here. So for this question, we want to find the possible function for this graph. Now to get factored form, we look at the zeros. So those zeros, so as you can tell, my zeros are 0, negative 4, and 3. And you see the bounce here because it's bouncing. So that 3, as you can tell right here, has a squared on it. Now, because this is 3, we use the opposite as a factor because when you plug in 3, 3 minus 3 is 0. Hint, that's why they're called zeros. So 3 becomes an x minus 3. It's squared because it's a bounce. This is x plus nothing, or x. And this is negative 4, so that would be x plus 4. Regular, no squared, because it's just a straight through. These are both straight through. Now, why is there a negative up front? Because on the right here, you're dropping. Anytime you drop on the right, it has a negative in front. Now, this could be a negative 2, a negative 3, or something in front, but we're going to just call it negative. Negative something. Next, standard form. Well, I could FOIL this and box this and multiply this all out. But I just want a possible function, not the exact function. So the two things I have to realize is my lead coefficient has to be negative. See the negative? And if I look at this, I got to figure out the degree. Now my degree, well, if I add 1, I'm adding my extremas. 1, 2, 3. 3 extremas plus 1 is 4. So this is a 4th degree, or an even degree. Now you could have, instead of knowing it's a fourth degree, you could also look at, okay, it's even because both edges are going down, but it's helpful to find the exact or a possible exact degree. Because of the extremas are 1, 2, 3, plus 1 is 4, the smallest this power could be is 4. And I know it also has to be an even number. So this could be a 4, a 6, an 8. As long as it's even, and it can't be smaller than 4 because of the extremas. Now, negative lead coefficient again is because it's dropping on the right, and the 3 extremas I talked about. Now, this helps. My y-intercept is 0, 0. So what that means is this number at the end has to be an output of 0, because your y-intercept is always this last number in standard form. So we actually know that there can't be a number here. Now, where to get these numbers? I just made up whatever I wanted, because it's a possible function. So we're really just looking at this right here and this. Negative, even, power bigger than 4. So this problem right here looks a little scary. F of x is a fourth degree polynomial with a relative max here and here, as well as a relative min here. Which of the following are true about f of x? So the first thing I want to do is plot the graph. So I plot these 3 points. You can see them down here in red. I do know that this max is at negative 4, 5. So I know at negative 4, 5 I have a max like that. Also at 2, negative 1 I also have a max. So I should have that shape at both of those. And 0, negative 3 is a min, so I know I have that shape here. And when I connect the dots, I get this shape. Now, the fourth degree here is very, very important, because a fourth degree tells us that both sides should go down. All right? So the only graph we could have is something like this, where the edges on both sides go down, and it has to actually hit those points at those maxes and mins. So the questions, 11 questions here, we're going to see which are true. Falls on the right. Yes, it does. Rise on the left? No, on the left is falling. Are there 3 real zeros? Now it says zeros. We're going to talk about real zeros. And no, there's only 1, 2 real zeros. Even though it's a fourth degree, that must mean there's 2 imaginaries hiding in there. So, but there are 2 real zeros. All right. So, which means there are 2 zeros. There we go. So that one is true because there's only 2. Next, decreasing on 0 to 2. So from 0 to 2, no, that's increasing. All right, increasing from 4 to 7. So from 1, 2, so 4 right here. Wait, 1, 2, 3, 4. I said 4 to 7, didn't I? Sorry. 4 to infinity. From 4 on, it's decreasing. See how it's dropping from 4 on? So you know that would not be increasing. Has a positive lead coefficient. So if it has a positive lead coefficient, it would be rising over here. But no, it's falling. So since it actually has a negative lead coefficient because it's falling on the right. Okay, next one. Average rate of change from negative 4 to 0 is negative 2. So this is negative 4. Okay, that dot's at negative 4. And to 0 is that dot. I went over 4 and down 8, which is a fraction of negative 8 over 4, which is negative 2. So yes, the average rate of change is the slope, and the slope is negative 2. So yes, we're good. Could have a 0 at x equals 2. So at 2, can it have a 0? No, it has a max. So there's no way it could have a max and a 0 at the same time when the 0 is not, sorry, when the max is not on the x-axis. So there's no way for it to actually touch right there. So x minus 3 could be a factor. Well, if x minus 3 is a factor, that means 3 is a 0. So can this graph possibly touch right there? And no, it's not, because if this is a max and it has to go down forever on the right, there's no way it could turn around and hit that. Because after that max, it has to keep falling. So it can never come back up and hit right there. So 3 cannot be a 0, so x minus 3 cannot be a factor. Now, if x plus 2 is a factor, here's why. Because negative 2 is a 0, could be a 0. Again, if negative 2 could be a 0, then x plus 2 could be a factor. And look right here. I know I didn't hit negative 2, but if I graph this, is it possible that that blue line could have hit right there? Yes, it's very possible, because again, I just sketched it through here. So it is possible for x plus 2 to be a factor. Possibly. We don't know for sure, though. So first thing you do with this kind of question is sketch it. Second thing is just go bit by bit through it and see which ones are true and which ones are false. Alrighty, so for this question, what is the least number of zeros a fourth degree polynomial could have? Well, can you see a fourth degree polynomial? Perfectly fourth degree, and there are no zeros. So I could have, anytime you have an even degree, you could have no zeros. It could just keep turning around above. That actually means there are 4 imaginary zeros. That's why there's no real zeros, no actual x-intercepts. Now, what is the most number of zeros a fourth degree polynomial could have? Well, the most is always the degree. The degree is the highest amount of zeros that you could get, real zeros you could get. So 4 because it's a fourth. So for a fifth degree, the least number of zeros is always going to be 1. Because an odd degree, one side goes up, one side goes down, so it always has to hit at least one spot. There's no way to get a 0 like an even degree. So it has to hit at least once. All these up here would be, you have 1 0 on this one, and then you have a whole bunch of imaginary zeros. All right, so what is the most? Well, again, like we said earlier, if it's fifth degree, the most is 5. And so you can see 5 right there. You can never have more zeros than the degree. What is the highest possible degree of a polynomial with 3 zeros? So see how I have 3 real zeros right there? So what is the highest possible degree? Well, if I go through that, I hit 3 times, couldn't I keep turning around over and over and over? And every time I turn